Lesson 7 of Chapter 4 is on the law of sines and the law of cosines. Day 1, we're going to focus on the law of sines. The law of sines will allow us to find missing angles or missing side lengths of a triangle that is not a right triangle. Here is the law of sines. It simply says the sine of angle A divided by length A is equivalent to the sine of angle B divided by length B, which is equal to the sine of angle C divided by length C. From geometry, you should remember that we use capital letters for vertices of a triangle. We use lowercase letters for sides opposite of those vertices. Shout out to Noah Dietz. How you doing, man? Good. You're part of my video today. All right, example 1 says to solve the triangle ABC, round your answers to the nearest tenth and the angle measurements to the nearest degree. So you can see on 1A, we have two angles and one side length. So we have to find angle T right here, and we'll also need to find length T and length S. Well, you know that the sum of the three angles of a triangle add up to 180 degrees. So if we add S and R, that gives us 114. And so if you take 114 and subtract it from 180, that gives us the measure of angle T. So that would be 66 degrees. So there's one of our missing pieces. Now to find length T, we use the law of sines, and we'd say the sine of 66 degrees over length T equals the sine of 63 degrees over length 13. And now to solve, we'd have to cross multiply and divide. And to get that T length, we're going to take 13 times the sine of 66. So 13 times the sine of 66, was it? Yep. 66. Now when we do this, you do need to check your mode. You should be in degree mode. As you can see, I'm in degree mode. If you're in radian mode, switch it over to degrees. So we're taking 13 times the sine of 66, then we're going to divide by the sine of 63. So that gives us 13.3 approximately. And now we still have one more piece to find, and that is to find length S. So to find length S, we'll use the law of sines, which says the sine of 51 degrees over length S equals the sine of 63 degrees over length 13. So now to solve this for length S, we'll take 13 times the sine of 51. And then we'll divide by the sine of 63. And that gives us about 11.3. So that's using the law of sines to find the two missing side lengths and the missing angle. Same type of example, if you look at 1B, we're given two angles. We've got one missing angle, and then we've got two missing side lengths. So to find angle K, we know the sum of the three angles adds up to 180 degrees, so 29 and 25 adds together to give you 54. So if we take 180 degrees and subtract 54 degrees, that gives us angle K, which in this case is 126. So there's your missing angle. Now we'll use the law of sines to find the two missing sides. So the sine of 25 degrees over length L would have to equal the sine of 29 degrees over 18. So then if we go to the calculator and cross multiply and divide, we'll take 18 times the sine of 25. And then we'll have to divide by the sine of 29. And that gives us 15.7. And now we still need to find length K. So to find length K, we'll use the law of sines, and we'll say the sine of 126 degrees over length K would have to equal the sine of 29 degrees over 18. Going to the calculator, we'll take 18 times the sine of 126. And then we'll have to divide by sine of 29. Gives us 30.0. And now we've solved for the two missing sides and the missing angle. So that's the first example. Now the next example is called the ambiguous case because this is different. The first example we were given two angles and a side length. If you look right here, we call it the angle side case. The next one is we're given two side lengths and an angle. So on this problem, to use the law of sines, you can see we've got two missing angles. They are angle C and angle B. And we have one missing side length, that is length B. So using the law of sines, we'll say the sine of 94 degrees divided by 15 would equal the sine of C over 12. So now when we cross multiply and divide, we're going to have to take 12 times the sine of 94 and then we'll have to divide by 15. And what we get is a value that is equal to the sine of C. Okay, so now to find the measure of angle C, we have to use an inverse trig function. We'll use sine inverse of that value right there, and that gives us an angle, which is 52.9, so we're going to round that to the nearest degree, 53 degrees. So now that we know angle C is about 53 degrees, we know that the sum of the three angles has to add up to 180 degrees. Thus, angle B would have to be equal to 180 degrees minus, let's see, if we add 94 and 53, that gives us 147. So that would be 33 degrees for angle B, approximately. So now we've got our two missing angles. Now we got to find our missing side length. So to find our missing side length, we take, let's see here, we're trying to find measure of angle B. No, we're trying to find length B. So we'll say the sine of 33 degrees over length B equals the sine of 94 degrees over 15. And on the calculator, we'd have to cross multiply and divide. Take 15 times the sine of 33. And then we'd have to divide by the sine of 94. And that gives us about 8.2. Last thing I always do when I'm doing these problems is to check to see if my answers make sense. You can see that angle A is the largest angle, it's 94, and so length A should be the longest, and it is, because it is 15. You can see that angle C is the next largest angle, 53 degrees, and so length C should be the next longest, which it is, it's 12. And then angle B is the smallest angle, 33 degrees, and so length B should be the shortest, which you can see it is, 8.2. So this is called the side-side angle case. Another example of that. Now, if you're not given a picture, I always think it's best to draw a picture and then label your sides A, B, and C. The picture does not have to be drawn to scale. And so you can see I'm going to put 61 degrees here for angle B. We're going to put length B as 8 and length A is 12. And so now using the law of sines, there's only one thing I can solve for to start this problem, and that's angle A. So we'll do the sine of angle A over 12 equals the sine of 61 degrees over 8. Using the calculator now, we have to cross multiply, so we'll take 12 times the sine of 61. And then we'll have to, whoops, delete that, divide by 8. And you can see it gives us a decimal, 1.3. And so the sine of angle A is equal to 1.3. And so if we do sine inverse of the 1.3, that gives us an error. Why does it give us an error? Because you can't do sine inverse of a number that's bigger than 1. So what that means is that there's no possible triangles that can be formed with this given information, having angle B be 61 degrees, length A 12, and length B 8.